Okay, we're given the graph of a quadratic function, and we want to find the function itself that would give us this graph. So to get started on this, I'm going to use the standard form for a quadratic function that's listed over there on the right-hand side. And the first thing I want to do is locate the vertex. The vertex on a parabola, what we call these graphs of quadratic functions, is this lowest point, or it could be a highest point if the graph had been flipped upside down. So it looks to me like that ordered pair is 2, -4. All right, that corresponds with h and k in our formula over on the right-hand side. Or another way I like to think about it is the standard x-squared graph has its vertex at 0, 0 at the origin, and kind of goes up from there. Sort of has that sort of look going. So I like visualizing this as that vertex has been moved to the right 2 and down 4 to be located at 2, -4. So if you have the formula, you're welcome to just plug in for h and for k, or if you were thinking about how do I build this up using what we've thought about with transformations, well, you would have to move to the right 2, so I'm going to attach a 2 in directly to x, and left and right movements kind of work the opposite way you think they should, so we're going to subtract 2 as opposed to adding 2. And then we want to move everything down 4, so I would want to subtract 4 from the entire function. Now what we haven't taken into account is there could be a stretch or a compression, there could be a scalar multiple out in front here. So I'm going to leave an a hanging out in front for the time being. Now the next thing you want to do to get through this type of problem is you want to pick out an additional point. An additional point that you are very confident is on our graph. So we picked out the vertex to get started. Now we want to find one additional point. So two contenders for this are either 1, -1 or 3, -1. I'm going to go with 3, -1. So that's an x value and an f of x or y value. I'm going to plug that into the function that we're creating over on the right-hand side. So -1 can replace f of x, and 3 can replace our x. Okay, from here we now have an equation that only has one unknown. We don't know what a is yet, but everything else is constants or numbers, so we can do a little bit of solving down and find a. So first I'm going to follow my order of operations and work what's inside the parentheses. So we have 3 minus 2 makes 1, raised to the second power, minus 4. In this case, I'm going to go ahead and add 4 to both sides. So -1 plus 4 makes 3. And then we have a times, when you have 1 squared, that's just times 1, so a is just equal to 3. To finish this up, I'm going to take that value, and I'm going to go back up and replace it back in where the a was. So our function really should be f of x equals 3 times x minus 2 quantity squared minus 4. All right, I hope this helps out as you work on finding a function that's going to give you the graph.